this session, we shall go through some more important concepts and problems in trigonometric identities. As the first problem, observe the question on the board. Tan of pi cos theta is equal to cot of pi sin theta, and 0 is less than theta is less than 3 pi by 4. Then what is the value of sine of theta plus pi by 4? He is asking us how to get it. Look here. Tan of pi cos theta is equal to tan of pi by 2 minus pi sin theta. Am I right? Tan of pi by 2 minus alpha is cot alpha. I am making use of that. Thereby, you have pi cos theta is equal to pi by 2 minus pi sin theta. Throughout the equation you can cancel pi, so that you have cos theta is equal to half minus sin theta. That is cos theta plus sin theta is equal to 1 by 2. And multiply throughout the equation by 1 by root 2. What is going to happen? 1 by root 2 cos theta plus 1 by root 2 sin theta is equal to 1 by 2 root 2. Okay. Sin theta cos 45 plus cos theta sin 45 is equal to 1 by 2 root 2. What about this? It's just nothing but sine of theta plus 45 degrees, or theta plus pi by 4 is 1 by 2 root 2. So this is the required one. What is the value of sine of theta plus pi by 4? 1 by 2 root 2. And this simple idea of course gives us the answer. Tan of pi cos theta is equal to tan of pi by 2 minus pi sin theta. Well done. This is the answer. Observe the steps carefully. The next question is, sin theta plus cos theta is equal to A, then what is the value of secant theta plus cosecant theta? Sin theta plus cos theta is equal to A, then what is secant theta plus cosecant theta? That is the question. Of course, one of the simplest questions. What is secant theta plus cosecant theta? First of all, you proceed in the middle of the steps, you will get the idea how to achieve. Very simple. Look here, what is secant theta? 1 by cos theta. What is cosecant theta? 1 by sin theta is equal to sin theta plus cos theta by sin theta cos theta. Sin theta cos theta. Well and good. Sin theta plus cos theta is just nothing but A by sin theta cos theta. By sin theta cos theta. Okay, so you must be able to have an idea what is to be written in the place of sin theta cos theta. Well, now use it. Square it on both the sides. Sin square theta plus cos square theta plus 2 sin theta cos theta is equal to A square. From this, 2 sin theta cos theta is equal to how much? A square minus 1. Am I right? Sin square plus theta plus cos square theta is 1. I have sent that 1 to that side. From this, sin theta cos theta, in the place of sin theta cos theta, what can you have? A square minus 1 by 2. So this is A by A square minus 1 by 2. It's nothing but 2A by A square minus 1. 2A by A square minus 1. So if sin theta plus cos theta is equal to A, then what is the value of secant theta plus cosecant theta? That is the question. And to approach that one, we have proceeded up to this step. Now, the situation demands that what is to be written in the place of sin theta cos theta? Answer for that question is required. Okay, you use the given item, that is sin theta plus cos theta is equal to A. He has given us make use of that to get sine theta cos theta, and in the place of sine theta cos theta you just put a square minus 1 by 2, so that the answer is 2a by a square minus 1 is the right answer. If sine theta plus cos theta is equal to a, then what is sine cube theta plus cos cube theta? What is sine cube theta plus cos cube theta? Well, the same data as that of the previous question. In the previous question also it has been given that sine theta plus cos theta is equal to a. Here also the data is that, of course, here the requirement of the question is sine cube theta plus cos cube theta. How to find the value? Let us now start. First of all, sine cube theta plus cos cube theta is equal to sine cube theta plus cos cube theta is equal to, come on, tell me, a cube plus b cube, a plus b whole cube minus 3ab into a plus b, sine theta plus cos theta. Okay, this is a cube minus 3 sine theta cos theta into sine theta plus cos theta is again a. Here also we need to have the value of sine theta cos theta, isn't it? This is a cube minus 3a sine theta cos theta. Call this equation 1. Well, sine theta plus cos theta is equal to a is given, square it on both sides. 1 plus 2 sine theta cos theta is equal to a square. Of course, sine square theta plus cos square theta plus 2 sine theta cos theta, and sine square theta plus cos square theta is of course 1. That is why I could have written it as 1 plus 2 sine theta cos theta. And from this, what is sine theta cos theta? Is just nothing but a square minus 1 by 2. Isn't it? Therefore, you can write this as a cube minus 3a into a square minus 1 by 2. Take the LCM. 2a cube minus 3a into a square minus 1 by 2. Well, friend, it is 2a cube, it is minus 3a cube. So, minus a cube will be remain. So, the ultimate answer is 3a minus a cube by 2. So, what is the answer for that question? 3a minus a cube by 2. Just like in the previous question, we have proceeded up to this point, and we have noticed that what is to be written in the place of sine theta cos theta, that is the need of the question. That is why I could have made use of the given item, that is sine theta plus cos theta is equal to a. After squaring it, of course, you will be having sine theta cos theta is equal to a square minus 1 by 2, and you just substitute this here in this place, so that you have the answer to be 3a minus a cube by 2 is of course the correct answer. You observe the next question. Oh, it looks so lengthier and bulkier. Of course, the problem is very simple. You first of all observe the data, the given items. There have been 3 angles, namely alpha, beta, gamma. They're all positive. We should feel happy. And their sum is pi by 2. What does it mean? Alpha is acute, beta is acute, and gamma is also acute. Okay, there are acute angles. Moreover, there have been given 3 separate letters P, Q, R. P is equal to 5 plus tan alpha tan beta. Q is equal to 5 plus tan beta tan gamma. R is equal to 5 plus tan gamma tan alpha. If such is the case, what is the maximum value of root P plus root Q plus root R? About that we have been asked. We're asked. Yes. How to get it? What is root P? Root of 5 plus tan alpha plus tan beta. Oh, it is a tedious job if you directly take root P plus root Q plus root R. Okay, and you are supposed to use every piece of information given here. Every piece of information you are supposed to use. And for this purpose, I like to consider root P plus root q plus root r whole square. What is a plus b plus c whole square? A plus b plus c plus 2 root pq plus 2 root qr plus 2 root rp. And this is the crucial place at which we are supposed to get the beautiful idea required to solve this problem. Next step is the crucial step. Well, let us recall one important concept from progressions. AM is greater than or equal to GM for any two numbers. That is, GM is less than or equal to AM for every pair of two positive numbers. Okay, so GM, you consider two numbers P and Q. Root PQ is the GM and P plus Q by 2 is the AM. So 2 root PQ is less than or equal to P plus Q, etc., etc., etc. In a similar fashion, 2 root QR less than or equal to Q plus R, 2 root RP less than or equal to R plus P. So this is less than or equal to P plus Q plus R plus PQ plus Q plus R plus R plus P. Altogether, this is P, 3P, 3Q, 3R. 3P, 3Q, 3R. 3 into P plus Q plus R. Well done. You add all of them. What is going to happen for P plus Q plus R? 5 plus 5 plus 5, 15 plus tan alpha tan beta, tan alpha tan beta plus tan beta tan gamma plus tan gamma tan alpha. And at this juncture, at this position, you may have to recollect one of the famous identities. And we need it. Yes. What is tan alpha tan beta plus tan beta tan gamma plus tan gamma tan alpha when alpha plus beta plus gamma is pi by 2? It is 1. It is one of the famous identities, you know. So this is equal to 3 into 15 plus 1. 15 plus 1 is 16, 16 3 is 48, isn't it? Therefore, what is your observation? Root P plus root Q plus root R whole square is less than or equal to 48. Therefore, root P plus root Q plus root R is less than or equal to root 48. Root 48 is nothing but 4 root 3. It's nothing but 4 root 3. Of course, my dear, in this moment, in this problem, we could have made use of one beautiful identity. What is that identity? Tan alpha tan beta plus tan beta tan gamma plus tan gamma tan alpha is equal to 1, of course, when alpha plus beta plus gamma is pi by 2. Well, of course, it is our duty to recollect all such important identities at once. Now, let us concentrate on those identities. What are they? How many are they? How can we prove them, or how can we recollect them, like that? We shall see the needy identities. Actually speaking, there is a long list of identities. But it's not enough to have all of them. It is just enough to have the needy items, special items. We shall now have them in our observation. That is, we would like to concentrate on important identities. The very first identity under this heading, that is, if A plus B plus C is equal to 180, is number 1. Sin 2A plus sin 2B plus sin 2C is equal to 4 sin A, sin B, sin C. It is one of the most standard results and identities. What is sin square theta plus cos square theta? 1. With sufficient ease, you will be able to say the answer as 1. With the same speed, with the same ease, you must be able to have the answer for this question also. If I ask you what is sin 2A plus sin 2B plus sin 2C, you must be able to recollect on the spot that it is 4 sin A sin B sin C. Correct? Good. Another such result. Cos 2A plus cos 2B plus cos 2C is equal to minus 1 minus 4 cos A cos B cos C. Again, two more results are also there. Sigma sin A, sin A plus sin B plus sin C is equal to 4 cos A by 2 cos B by 2 cos C by 2. While solving the problems regarding properties of triangles, we will use all these more frequently. Okay, sin A plus sin B plus sin C is equal to 4 cos A by 2 cos B by 2 cos C by 2, and cos A plus cos B plus cos C is equal to 1 plus 4 sin A by 2 sin B by 2 sin B by 2. You observe the difference between these two. Well, my dear, this is a good bunch of identities regarding sine function and cos function. Why I am saying this is these 4 formulas will stand as answers or hints to solve many questions. For example, if any person asks us what is cos square sigma cos square A in a triangle, cos square A plus cos square B plus cos square C. Cos square A is 1 plus cos 2A by 2. So it is sigma 1 plus cos 2A by 2. Isn't it? That is 3 by 2 plus sigma cos 2A, that is minus 1 minus 4. Sigma cos 2A is nothing but this. In a similar fashion, suppose he asks you what is sigma sin square A. What is sigma sin square A? Sigma sin square A is nothing but sigma 1 minus cos 2A. Again, you will be able to use sigma cos 2A. Let us observe that sigma cos square A. What is sigma cos square A? Is nothing but sigma 1 plus cos 2A by 2. Isn't it? Okay. This is equal to half into 3 plus sigma cos 2A. Am I right? 1 plus cos 2A plus 1 plus cos 2B plus 1 plus cos 2C. 3 plus sigma cos 2A. What is sigma cos 2A? Here it is. Isn't it? So, this is half into 3 minus 1 minus 4 cos A cos B cos C. Three minus 1 is 2. Half of 2 is 1. Half of 4 is 2 minus 2 cos A cos B cos C. That's all. We are able to have sigma cos square A. So, you need not remember this. You remember this. This gives so many answers. So, this is the basic formula and this is an application. So, we do not like to write this in the list of identities. Even though it is an identity, it is not immediately necessary to remember them. Why? Because it can directly be deduced from sigma cos 2A. Again, suppose sigma sin square A is required. What do you mean by sigma sin square A? Sin square A plus sin square B plus sin square C. If there is a question regarding this sigma sin square A, what is sigma sin square A? Sigma 1 minus cos 2A by 2 is equal to half into 1 minus cos 2A plus 1 minus cos 2B plus 1 minus cos 2C is 3 minus sigma cos 2a. Isn't it? But sigma cos 2a is that much, minus 1, minus 4, etc. If you replace sigma cos 2a by this number, what are you going to have? Half into 3 plus 1 plus 4 cos a cos b cos a. 3 plus 1, 4. Half of 4 is 2. Isn't it? You can get 4 out, so that this is 2 into 1 plus cos a cos b cos a. This is the matter of sigma sine square a, isn't it? Sigma sine square a. So to have sigma sine square a, we are making use of sigma cos 2a. This is helpful in so many other identities, other necessities to solve other problems also. Okay, let us observe 2 more such results which are based on these. What is sigma cos square a by 2? What is the meaning of the question actually? Cos square a by 2 plus cos square b by 2 plus cos square c by 2. Okay, instead of cos square a by 2, I would like to write 1 plus cos a by 2. Isn't it? So it is half into 1 plus cos a plus 1 plus cos b plus 1 plus cos c. It is nothing but 3 plus sigma cos a. 3 plus sigma cos a. Well, my dear friend, in the place of sigma cos a, what are you able to write? 1 plus 4 sin a by 2 sin b by 2 sin c by 2. It's nothing but half into 3 plus 1 plus 4 sin a by 2 sin b by 2 sin c by 2. Three plus 1, 4. 4. If you can get it out, so you will be having the answer as 2 into 1 plus sin a by 2 sin b by 2 sin c by 2. This is about sigma cos square a by 2. Sigma cos square a by 2. If at all it is asked, we write like that. So this result is of course dependent on this identity, cos a plus cos b plus cos c. So you please remember this, but not this. Why? This can directly be deduced, rather deducted, this extracted, rather obtained from cos a plus cos b plus cos c. There has been one more result that can be directly derived from this. What is that? The another identity, sigma sine square a by 2. What is sigma sine square a by 2? Sine square a by 2 plus sine square b by 2 plus sine square c by 2. That can also be directly obtained by making use of identity number 4. How? This you can write it as 1 minus cos a by 2. Let me get half out into what is sigma 1 minus cos a. 1 minus cos a plus 1 minus cos b plus 1 minus cos c. That is 3 minus cos a plus cos b plus cos c. That is half into 3 minus sigma cos a. Okay friend, what is sigma cos a? Cos a plus cos b plus cos c. We could have already obtained. What is it? 1 plus 4 sin a by 2 sin b by 2 sin c by 2. Hence the answer is half into 3 minus 1 minus 4 sin a by 2. Three minus 1 is 2, half of 2 is 1. Half of 4 is 2. 2. That's it. This is about sigma sine square a by 2. Isn't it? So, these are the most useful formulae which can be used in multiple ways. Yes. Well, these are the identities which are needed very much regarding sine function and cos function. If a plus b plus c is equal to 180, Well, there are some more identities regarding tangent function, that is tan function also. How can they look? How can they be used? How can they be obtained? We shall now look at them. Change. The next identity, which is very important, which is under use at so many contexts, yes, is if a plus b plus c is equal to 180, rather pi, then tan a plus tan b plus tan c is equal to tan a into tan b into tan c into tan c. Frankly speaking, this result is true even when a plus b plus c is n pi. That is, if a plus b plus c is 0, a plus b plus c is 180, a plus b plus c is 360, 5 or is 720, how many multiples of pi you can have? At all those cases, this stands true. Okay, how can it be? How can it be made true? It's very simple. You take tangent on both the sides, so that tan of a plus b plus c is equal to tan pi is equal to 0. What is tan 180? 0. Do you remember the formula for tan of a plus b plus c? What is its numerator? Tan a plus tan b plus tan c minus tan a tan b tan c is equal to 0, isn't it? It is one of the simplest results. What is tan of a plus b plus c? Tan a plus tan b plus tan c minus tan a tan b tan c by 1 minus tan a tan b tan c tan c tan a is equal to 0. Therefore, the numerator becomes 0. So, this is 0. Sigma tan a is equal to pi tan a. What do you mean by pi of that? Product of that. There is a tan a plus tan b plus tan c is equal to tan a tan b tan c. Tan a tan b tan c. Well, my dear, I would like to do one thing here. If a plus b plus c is equal to pi by 2, then tan pi by 2 is infinity. Infinity means denominator is 0. Means 1 minus tan a tan b minus tan b tan c minus tan c tan a is equal to 0. That is, tan a tan b plus tan b tan c plus tan c tan a is equal to 1. We could have made use of this identity just previously in some problem. Just 10 minutes back, we have used it. So, by making use of this formula, you will be able to have two identities. What are they? One thing is, if a plus b plus c is equal to pi, then tan a plus tan b plus tan c is equal to tan a tan b tan c. And if a plus b plus c is equal to pi by 2, then tan a tan b plus tan b tan c plus tan c tan a is equal to 1. That is, sigma tan a tan b is equal to 1. Yes, tan a plus tan b plus tan c is equal to tan a tan b tan c, and cot a cot b plus cot b cot c plus cot c cot a is equal to 1. Is equal to 1. Tan of a plus b plus c is, I'm sorry, it is pi, not pi by 2. Previously we had changed it, you know. No. With pi only we have to take it. Yes. If a plus b plus c is equal to pi, then tan a plus tan b plus tan c is equal to tan a tan b tan c, and cot a cot b plus cot b cot c plus cot c cot a is equal to 1. Similarly, tan a by 2 into tan b by 2 plus tan b by 2 into tan c by 2 plus tan c by 2 into tan a by 2 is equal to 1. If a plus b plus c is 180 degrees, then a by 2 plus b by 2 plus c by 2 is 90 degrees. Previously itself we have seen what happens when a plus b plus c is 90. Of course, in the place of a plus b plus c, we have a by 2 plus b by 2 plus c by 2. What is there? Their sum is 90. So that we have tan A by 2 tan B by 2 plus tan B by 2 tan C by 2 plus tan C by 2 tan A by 2 is equal to 1. What happens, the result regarding cot functions involving A by 2, B by 2, C by 2? This is like that. Tan A plus tan B plus tan C is equal to tan A tan B tan C. Cot A cot B plus cot B cot C plus cot C cot A is equal to 1. This is the second one. That is, those two are the identities with respect to A, B and C. And if you want to consider A by 2, B by 2, C by 2, then sigma tan A by 2 tan B by 2 is equal to 1 and sigma cot A by 2 is equal to pi cot A by 2. These are the famous identities in triangles, of course, because A plus B plus C is equal to pi or 180. And these are very much under use. At so many occasions we will be making use of these identities. Well, let us now observe some more formulae in which these identities can be used.